Okay, welcome back. We're going to do 2 lessons today, both involving applications of systems of linear equations. So basically we're going to do a whole bunch of problem solving. Okay, so page 641. And unfortunately when I printed these out, my highlighting crossed through like that, but I'm sure you guys will get it figured out. So we've discussed 3 different methods for solving systems of equations. So we could just graph it, okay, and do y1, y2, and then we find their intersection point. Okay, so definitely make sure that you are adept at doing that on your calculator. Okay, we used substitution, which is my personal favorite. So basically if you've got 2 equations, 2x plus 3y equal to 15, you just solve the equation for one of those variables and then substitute it in. And then elimination, which is what we did yesterday, where you rewrite it. So if we've got that, you would rewrite this as, you know, x plus 5y, just making things up. And then you would subtract the 2 to get rid of the one variable. So either way, for substitution and elimination, your goal is to get it down to one variable and then substitute in to get the second variable, so that at the end you have 2 variables in the form of, you know, what is x equal to, what is y equal to, which is what your intersection point is. That's your solution. Okay, so we're going to apply all these methods to problem solving. So we can solve a variety of types of problems using systems of equations, and there's this 4-step method here that we can follow. So step 1, you introduce variables. So that's your let x statement. So let x equal, you know, number of pants, and let y equal number of shirts. Okay, so introduce the variables to represent the unknown values. And so because it's a system, we're going to have those 2 variables. Step 2 is to form a system of equations involving the variables. So a system of equation means you're writing out 2 different equations. So usually in the form of y is equal to mx plus b, or it could be in the form of ax plus by plus c equal to 0. It just kind of depends, and we'll go through lots of examples to show this. Okay, then you're going to solve the system either graphically or through elimination or through substitution. Then you just overall answer the problem and then check your solution. Sometimes you might have a solution that doesn't actually work with that problem. So I think we've talked about a little bit, like if you got 2 solutions, for example, if we're talking about time and you get a negative, like -5 seconds, we can't go back in time yet, right? So then we would have to discount that. But those more happen in next year. So in 20-1 and 20-2, we look at quadratics. Okay, so that's going to be like x squared plus x plus 3 is equal to 0, as opposed to just like y is equal to mx plus b kind of thing. Anyway, we're going to do a lot of the same stuff, just with quadratics next year. That's the focus. Grade 10 is linear equations. Okay, so let's start off with an example. So number applications. So the difference between 2 numbers is 9. So now when you see the word difference, you should think subtraction. Okay, and we know we've got 2 numbers. So one of them is going to be x, one of them is going to be y. The larger number is 3 more than twice the smaller number. Okay, 3 more means you're adding 3. Twice the smaller number means you're timesing by 2. Okay? So find the numbers. So we're going to go through our system. So we made some jot notes here, and we're just going to pull it all together so we can solve this. So introduce the variables. So we're going to let x equal the, oops, open up the wrong page here. One of the numbers, and it doesn't really matter, you just pick which one. So let's let x equal the larger number, which means y is the smaller number. Okay, so that's our first step, is to introduce the variables. Second step is to form the system. Okay, so this first part said the difference between the 2 is 9. So that's our equal sign. So x minus y is equal to 9. Okay, the other system, it states that the larger number, so larger number, is 3 times more than twice the smaller number. Okay, so what that means is, so our larger number, we stated here, is, so there's our equal sign again, 3 more, so that's just plus 3, then twice the smaller number. So that's going to look like that. Okay, so the larger number is 3 more than twice the smaller number. Okay, so we've got our system. Step 3 is we're going to solve it. Okay, so you could graph this. Okay, you would graph it, and then whatever the intersection point is, that would be your solution. However, let's do it with substitution. You could, of course, also do it with elimination. You will get the same answer each way. Did I spell that right? Substitution, yeah. Okay, so this right here, I actually already have it in terms of x. So all I need to do here is plug in this 2y plus 3 into x. Okay, so instead of x minus y, okay, well, if x is equal to 2y plus 3, okay, 2y plus 3 is my x, minus y is equal to 9. Okay, then I'm going to combine my like terms. 2y minus y is y. I'm going to send that 3 over. There we go. Okay, so 2y minus y is y. Here I would have to subtract that 3, and then I get y is equal to 6. Okay, so then that's my first answer. Now I just need to substitute this in, which I can substitute it into. Either one of these is fine, but I'll just do this one right here. Okay, or actually it'll be easier to do this one. So x is equal to 2, so now my y is 6 plus 3. 2 times 6 is 12. 12 plus 3 is 15. So there we go. So then I'm at step 4, answer the problem and check the solution. Okay, so step 4, the smaller number is 6. The larger number is 15. Okay, and then I do need to check my solution, which is also called verification, which you just need to substitute them in. So my first equation, x minus y is equal to 9. Second equation, x is equal to 2y plus 3. So essentially we're just going like left side, right side. So left side, right side, left side, right side. So my x is equal to 15 here. So 15 minus 6, my right side is 9. 15 minus 6 is 9. So therefore that one checks out. In this equation, x is 15. Right side is going to be 2y plus 3, which is going to be 2 times 6 plus 3. 2 times 6 is 12. 12 plus 3 is 15. There we go. Okay, so I've hit all of my 4 steps in answering this question. Okay. And like I said, you could have solved this with elimination. You could have solved it with graphing. If it's a short answer and you need to show your work, then you have to pick either substitution or elimination. But if this was a multiple choice question, you could definitely just use graphing. You'd have to like do a little bit. You'd have to get your your 2 systems, but then you would graph. All right. A couple more examples. So perimeter. The perimeter of a rectangle is 40 meters. Okay, so let's, with our recall, perimeter of a rectangle is twice the length plus twice the width, okay, because the perimeter is just the sum of the outside edges. Okay, the width is 4 meters less than the length. Find the dimensions of the rectangle. So find the dimensions, that means, okay, what is L, what is W? Okay, so we need to make our let and statement. So we can just use L and W. So we're going to let L equal the length and W equal the width. And we already have our first system right here. 2L plus 2W is 40 meters. So there's my equal sign again. So I can say 40 is equal to 2L plus 2W. I have another piece of information. The width is, so there's my equal sign. So width is 4 meters less than the length. Okay, so that means I've got the length and I'm taking away 4 meters. Okay, so there are my two systems that, once again, I could use graphing. I'd have to rearrange these both into y is equal to mx plus b, which is easy enough. You just move things around, right? Or you can do substitution, or you can do elimination. Anytime you have a variable all by itself already, it's much quicker just to use substitution. So if w is equal to L minus 4, that means we're going to put L minus 4 in for this w. So 40 is equal to 2L plus twice of, so now L minus 4, because this used to be x, or sorry, w. Okay, and then we just have to expand it, so we're going to have to distribute that 2. So 2 times L is 2L, 2 times negative 4 is negative 8, 2L plus 2L is 4L. Okay, and then this 40 was just chilling on this side. So I'm going to move that 8 over, so negative 8 plus 8 is 0, 40 plus 8 is 48, and then I'm going to need to divide by 4 so that I just have L by itself, not 4L, which is 12. Okay, so that's the first thing. Or I guess it's not the first thing, it's the first one to solve. Now we need to substitute this back in, okay, to there. So W is equal to 12 minus 4, which is 8. So we've got the width is 8, the length is 12. Then we just need to do our check to make sure left side is equal to right side. So 40 is equal to 2L plus 2W. Oopsie, that's my left side. Right side. Okay, twice of 12 plus twice of 8. Twice of 12 is 24. Twice of 8 is 16. 24 plus 16 is 40. Okay, and then we would check our other one. Same thing, W is now 8. L, 12 minus 4 is 8. Verified. Okay. All right. So money applications. And so the next two we'll do elimination, just so that we do an equal number of elimination and substitution. Although, like, if it doesn't specify, just use whatever way you feel most comfortable with, because then you'll ensure that you make, the fewest amount of errors. Okay, Gary has a total of $260 in $5 bills and $10 bills. So those are our two different things. So let's say that $5 bills is my X and Y is going to be my $10 bills. It doesn't matter which one's which, we just pick one and then go with it. Okay, so he has a total of that $260 in X, which is $5, and Y, which is 10. If he has 33 bills in total, so that's going to be another system right there, or another equation. How many of each denomination does he have? So denomination means the $5 and the $10. How many of each? Okay, so we've already said that we're going to let X equal the $5 and let Y equal the $10. So if he's got $260 total, okay, and he's got, so each $5 bill is $5, because this is all money, right? And then plus the $10 worth of the actual number of $10 bills. So there's our one equation. The second part is we know he's got 33 bills total. So that's my X plus Y. So the number of $5 and the number of Y. So I would personally just use substitution again for this, but just for the sake of showing this, we're going to do elimination. So I think, okay, what would I need to multiply this by? The smallest number possible to ensure lower error that I can use, so that I can use elimination, and that would be to times this by 5. Okay? So 133 times 5 is going to be 165. and then this is going to be 5x plus 5y. Okay, and then what I'm going to do to these two equations is I'm going to subtract them. Okay, so 260 subtract 165 is 95. (5x) subtract 5x. Okay, well that cancels those out, which is the whole point of eliminating, or elimination. You eliminate a variable. 10 minus 5y is 5y. Okay, and then we just have to divide by 5. And we get y is equal to 19. So that means I have 19 $10 bills. So then all I have to do is substitute it back into here. Okay, so if I have 19 $10 bills, I have, once I subtract my 19, I'm going to have 14 $5 bills. Okay, so that's the number of $5 bills. This is the number of $10 bills. Okay, and then you just do your check with your verifying with left side, right side. So we'll start with this first one. 260 is equal to 5x plus 10y. Left side, right side. So left side is 260. Right side is 5 times my 14 plus 10 times my 19. So you'd go ahead and plug that into your calculator, and this indeed would work out to be 260. So that's good. Okay, and then you would do for your other, where is it? There it is, 33. 33 is equal to x plus y. Left side, right side, 33. X plus y, 14 plus 19, is also 33. There's our check. Okay. So we just used elimination there for the system of equations to solve that problem. One more question. So another money problem. This time we're dealing with percent, interest, etc. Okay, but still the same steps. We're still going to do our let statements, make our systems, plug in, etc. Okay, so Laura invested her inheritance of $48,000 into 2 different mutual funds. Okay, so the 2 different mutual funds, those are going to be our X's and Y's. At the end of 1 year, one fund had earned 10.5% interest. Okay, so let's say let X equal the one that earns 10.5%. Okay, and the other fund earned 12%. If she received a total of $5,520 in interest, how much did she invest in each mutual fund? Okay, so we're still just solving for X and Y. Okay, so let X be the first fund and Y equal the second fund. Okay, so she invested it into the 2 different funds. So that means that X plus Y was equal to $48,000. Okay, so this is the first investment. I'll put the word investment. I'll spell it right. Second investment. So it's actually like the monetary value. Okay, and then this interest part, okay, that's where the $5,500 comes in. Okay, so that $5,500 and 20. Okay, the whatever she invested got that much interest. Okay, so let's just do a little aside on the interest, because remember, whenever we've got percents in math, we need to convert it to a decimal, which percentage we need to divide by 100, because percent, if I say per, that's the division, and then cent, that's 100. So 10.5 divided by 100 is going to be 0.105, because I just moved that decimal place over twice. And then that 12% is going to be 0.12. So in order to gain that interest, that first amount made that amount of interest, and the second amount made that amount of interest. Okay? So once again, I would just scoot that y over and then substitute it in for that x, but you can also solve this using the elimination. It's gonna mean doing 2 things. So in order to get these to be equal, okay, I would multiply this by 100, okay, so that I was back up to 10.5 and 12. Okay, and then so that 12y, so this one's decimal, I probably wouldn't deal with it. This one at 12y, I would need to multiply this by 12. Okay, so like I said, I would totally just do this with substitution, but I'll show this just so that you can see how it goes down. Okay, so the first one, 12x plus 12y, and then 48,000 times 12 is 576,000. Okay, and then these ones multiplied by 100, I just have to move that decimal place 2 places. Now the 12y's are those are the ones that are gonna cancel out, and then 5,500. There we go. So then these are the ones that I'm going to subtract. So 12y minus 12y, those disappear. 12x minus 10.5x is going to give me 1.5x. And then these two numbers subtracted, I'm going to have 24,000 left over. Okay, and since I've got 1.5x, I divide by that coefficient, and that gives me $16,000. So my first investment was $16,000. Okay, so I'm not done yet. I have to now solve and plug in. So I would use this easier one here. So x plus y is equal to 48,000. Okay, well that's going to give me 16,000 plus y is equal to 48. Okay, and then I'm going to scoot that 16,000 over there. 48,000 subtract 16,000 gives me 32,000. There we go. Okay, and then the last thing I would do, okay, was just to check that they are right, and I would just do my left side, right side, or another way of checking would be to convert these into y is equal to mx plus b and then graph the two of them. Okay, but you just literally plug them in again. Okay, so you can pause me here until second class and work on that assignment, and then I'm just going to continue on to the next lesson. Okay, so this is the last lesson of 10-C math. Congratulations, you made it. Okay, so we're still doing applications of linear equations, but we're going to be focusing on mixtures. So mixtures of food, mixtures of chemicals, and then also distance, speed, and time problems that you probably saw or hopefully remember from Science 10. We're going to look at how to do that because these time problems, distance, speed, time problems, do come up again in the -1 and the -2 math. Actually, a little bit in the -3 math as well. Okay. So, we've got cashew nuts costing $22 a kilogram are mixed with Brazil nuts costing $16 a kilogram. Okay, well let's let C equal the cashews and B equal the Brazil. Okay, and it's the actual amount of kilograms, so the number of kilograms that we care about. Okay, so cashews cost $22 per kilogram. They're mixed with Brazils, which cost $16 per kilogram. The total mixture weighs 50 kilograms and sells for 18 kilograms. So if we just think about this logically, 18 only has a difference of $2 from the Brazil, $4 from the cashews. So that tells me that the amount of Brazil nuts is going to be larger. Okay? So that's just something to kind of think about, because then that helps you when you get your answer. If you got your answer that was something different to that, that would give you your hint to, okay, maybe I made an error. Let's go back and look. Okay, so from that information, we know that the amount of cashews, which are worth $22, are mixed with the amount of Brazil nuts, which are worth $16, and that totals 18 kilograms, okay, or $18 per kilogram for that 50, okay? So that's going to be the $22 for the cashews and the $16 for the Brazil nuts, which is going to equal the $18 per kilogram, and we have that it's 50 kilograms. Okay, and that 50, remember, that's our cashews plus our Brazil nuts. So that actually gives us our second equation. We know that the amount, the number of kilograms of C plus the number of kilograms of B is equal to 50. Okay? All right, so I would just rearrange this to solve for, say, B. And then I would just substitute that in. I would use substitution on this one. Like I said before, if you like elimination, go hard, use elimination. You're going to get the same answer. Okay, so I'm going to substitute this in for that and get 22C plus 16 times 50 minus C. Okay, oh, excuse me. So I'm going to distribute okay, and I get those numbers. So now all I have to do is combine my like terms and solve for C, my variable. 22C minus 16C is going to be 6C. And then I'm going to scoot that 800 over. Okay, so I've got 6C is equal to 100. So then when I simplify that down, 100 divided by 6 is going to be equal to 50 divided by 3, which is 16 and 2/3. So you probably just put it into your calculator and got 16.666666. That 0.6666, that's the 2/3. Okay? And that represents kilograms. So then, put a box around that. Now I'm going to use one of my original equations to solve for B. So 16 and 2/3 plus B is equal to 50. Okay. And so then that's going to equal, when you do the math there, it's going to be 33.33333 repeating, which that 0.33 repeating is, of course, the 1/3. There you go. So the mixture had 16 and 2/3 kilogram of cashews, bless you, just kidding, and 33 and 1/3 kilogram of Brazil nuts. Okay, and you would still want to do your check of left side, right side for both these two equations. Okay, and just because I'll do it still, we're kind of running out of time, so 22, C is 16 2/3 plus 16 times 33. Oh, and we should talk about our answer. That's equal to 900. So remember we said that there was going to be definitely heavily weighted towards the Brazil nuts, and we see it's twice as much Brazil nuts, which makes sense. Okay, so you would plug this into your calculator, and sure enough you would get 900. So left side is equal to right side. Good. And then you would do that over here. Okay, so 33 and 1/3 plus 16 and 2/3 should be equal to 50. Okay, all right. Earl the chemist has to make 180 milliliters of 60% hydrochloric acid solution. Okay, so that's going to be like our total. He has available a 1 liter bottle of 45% solution and a 1 liter bottle of 70% solution. So he can mix those down to get to 60. And just looking at the differences, this is a 15% difference, this is a 10% difference. Okay, so we're probably going to have more of the 70% to get it up. Okay, how many milliliters of each solution are mixed to make that 60%? Okay, so our let x statement. Let's let x equal the number of milliliters of the 45% hydrochloric acid, and we'll let y equal the number of milliliters of 60% HCl. Okay, so that's the first stop. Now, we know that we have to make 180 milliliters of it, so that means that x plus y is equal to 180. And we also know that percentages they're all going to affect each other too. Okay? So we're going to have 0.45% of x plus 70% of y is going to be equal to 60% of them added together. Okay? And then once again, just like with our mixture from above, okay, that's going to be equal to 180 right off the bat. Okay? So I would also just use substitution again because I've just got my single variable. I would move that y over and substitute it in. Okay, so then x is going to equal that. Oopsies, this is 180. Okay. All right, so now that I've got that all plugged in, I'm going to distribute. Okay, so 0.45 times, oh, I need to get my calculator. Oopsies. 81. There we go. Okay, so now I just need to combine my like terms, which are right there, and then send that 81 over. Okay, so 0.7 subtract 0.45. 0.7 subtract 0.45 is 0.25. Okay, and 108 subtract 81 is 27. So then I'm going to divide by my coefficient. So 27 divided by 0.25, which is 108. So y is equal to 108 milliliters. And that's representing the amount of my 60% hydrochloric solution. Okay? So then I need to substitute it in to any one of these. I think the first one's easiest. So x plus 108 is equal to 180. So then when you subtract that, 180 subtract 108 is 72 milliliters. So that makes sense. We said that there would be more of the 60%, and there is. Okay, and then you would also do your check, make sure left side is equal to right side. But in the final answer, at least, you would say you would need 108 milliliters of the 60% and 72 milliliters of the 45%. To make a total of 180 milliliters, oopsies, of the, oh, this is supposed to be 70. This is supposed to be 60. There we go. So this is our final answer. And you would also perform the check that we've done a million times. Left side is equal to right side. Or you could graph them. Okay? All right. Okay, so now we're going to talk about distance, speed, and time problems. So this triangle you might remember, it helps us solve. So the velocity of something, or the speed, is equal to the distance it's traveled divided by the time. So speed, if I'm trying to solve for it, I would cover it up in the triangle, and then this horizontal line represents this horizontal line of division. So speed is equal to distance over time. If I want to find time, that's going to be distance over speed. And if I want to find distance, now that they're next to each other, that's going to be multiplication. So speed times my time. All right? So now any of these distance, speed, time problems, it's super helpful to make a distance, speed, time table. Okay? So we're going to look at that, but distance in speed time. It doesn't really matter the order that you put them, but they're going to be a table like this, and we're going to fill it out. Okay, so a student drove the 1,245 kilometers from Edmonton to Vancouver in 16.5 hours. Okay, so I've got kilometers and I've got hours, so I'm just going to pop those in. This is kilometers. My speed is going to be kilometers per hour then. Okay. This included a 1 hour stop in Golden and a 30-minute stop in Kamloops. She averaged 100 kilometers an hour on the divided highways and 75 kilometers per hour on the non-divided mountainous roads. So there's our two variables right now. So we've got the highway and then we've got the mountainous roads. Okay, so these tables will always have those two variables, just like any system will. Okay, how much time did she spend on the divided highways? So this is what we're trying to find out. Okay, so a couple things that we need to get from here. So we know her speed. She averaged 100 kilometers per hour here and 75 kilometers per hour here. We know that it took a total of 16.5 hours. Okay, 1 hour stop in Golden, 30-minute stop in Kamloops. So out of that 16.5 hours, we would subtract the 1 hour stop and subtract the half an hour stop. So the total time is 15 hours. Okay, and we're just going to use our X and Y. So we'll say that the time for highway is X, the time for the mountain is Y. So therefore, the amount of both added together is going to be equal to 15. Okay, so then for my distance, remember, if I were to cover up distance, I multiply my speed and my time. So that's going to give me 100x and 75y. Okay, and my distance, remember my total distance is 1,245 kilometers. So total, all I have to do is add those two together. Okay, so I've got one system here and another system there. So probably easiest just to solve for this. So y is going to be 15 minus x, which then I'm going to substitute in here and then solve down as per usual. Okay, distribute that. Okay, combine my like terms, so 100 minus 75 is 25. 1245 minus 1125 is going to give me 120. Okay, and then we'll just convert that to 4.8. I think I just need to, oopsies, what did I do? 0. 120 divided by 2.5. No, not 2.5. 120 divided by 25 gives me 4.8. Good, good. Okay, that's it. We're done. Because the question just asked how much time did she spend on the divided highways. 4.8. So then you, that would be in hours. You would also want to do a check. The reason why I'm not doing it is because I'm recording these at lunch and I'm afraid I'm not going to have enough time. But you should do the check by substituted in, sub into both equations to make sure that left side is equal to right side. You should always do that. Okay, so a small cruise boat took 3 hours to travel, so 3 hours to travel 36 kilometers down a river with the current. So if you're going with the current, it's helping you. Okay, on the return trip, it took 4 hours against the current, so now it's working against you. Find the speed of the current and the speed of the small cruise boat in still water. Okay, so our two things going on is we're going downstream and upstream. Okay, other than that, our table is going to look just like our distance, speed, time from above. So distance in kilometers, time in hours, and speed. And I did it a different order, and that's okay. Okay, so some of the things that I know that it took 3 hours to travel down the river, so then I would put a 3 there. It took 4 hours to go up the river, so I would put a 4 there. What else do I know? Okay, well, we need to do our let. So let x be the kilometers per hour, okay, in kilometers per hour. That's going to be the speed of the boat in the still water, because that's what I want to find out, right? Which means I'm going to let y, in kilometers per hour as well, be the speed of the current. Okay? All right. So, remember my distance, speed, time here. Okay? So if my, actually before I do that, sorry, back to talking about going with the current and without. Okay? So when I'm going downstream, I've got the speed of the boat and the speed of the current. It's helping me. When I'm going upstream, okay, I've got the speed of the boat, but the speed of the current is working against me. So whenever you're going upstream, you're going to subtract the speed of the current from the speed of the boat. Okay, now we're going to use our distance speed triangle. Okay, and for our distance, I'm going to multiply these two together. So it's going to be 3, dang, it's going to get loud in here while you guys come in, but that's okay. Okay, so we've got our table filled out. I also know that my total distance was 36 kilometers. Okay, so my distance downstream and my distance upstream is the same. Okay, so I've got 3x plus y is equal to 36, and 4x minus y is equal to 36. Okay, so then I can just, for this first one, I would divide both sides by 3. 36 divided by 3 is 12, and then I would scoot that y over and get 12 minus y. Okay, and then all I have to do is substitute this in to my second equation. Okay, so 12 minus y is equal to 36. Okay, so now we just need to solve. So 36 divided by 4 is 9. Okay, minus y is going to give me negative 2y. I'm going to scoot the 2y over here and the 9 over here. Okay, and so then I divide 3 by 2. Ran out of room here. 3 divided by 2 is 1.5. And remember, that's kilometers per hour. Okay, and then I just need to substitute it back into any one of these equations. So let's do this one. So the x plus 1.5, so I'm just substituting that 1.5 into that y there, is equal to 36. Divide by 3. Okay, and then subtract that 1.5. X is equal to 10.5, oopsies, 5 kilometers per hour. Okay, so sorry that was rushed. Okay, but so then that would be the solution. Then you would do your check to make sure that left side is equal to right side for both of these. Okay, I hope that was all clear. We can talk Monday if you have any questions. And yeah, work hard, get as much done, and have a great weekend.